The San Diego Supercomputer Center is a national resource center that supplies high-performance computing resources to the national research community. Our goal is to support at least 10,000 scientific researchers. Every time you increase the power of a scientific tool, you can ask questions that you've never been able to ask before.
San Diego Supercomputer Center is a National Science Foundation funded center. Right now we run two national systems, Gordon and Comet. Comet is a Dell HPC cluster designed around Dell PowerEdge C-Series servers. Comet was the first national system proposed and accepted by the NSF to provide HPC using virtualization. One of the great parts about building and maintaining Comet has been results like the Open Science Grid supporting the LIGO discovery of gravitational waves.
LIGO stands for Laser Interferometer Gravitational Wave Observatory. LIGO is trying to detect gravity waves as they come from space through Earth. They detected a gravity wave. They think that the origin of this wave is two black holes inspiraling. The two black holes collide and merge, and that last fraction of a second is what has been measured. Given that such a gravity wave had never been detected before, they needed to make absolutely certain that they understood what the probability is for just random noise to mimic such an event and measure exactly what is the most likely origin of that wave. And those algorithms to resolve the picture require large-scale computing. LIGO used Comet as part of the infrastructure that made that measurement. Comet, with its virtual cluster interface, can make that happen.
The Open Science Grid came in and built a virtual cluster on Comet. This was critical for them because before that, they normally have to write another software abstraction layer to interface with that one-size-fits-many environment. Those software barriers slow down the parallel applications that are the whole point of parallel computation. With Comet, we overcame this through single root I/O virtualization that was developed by Mellanox.
Single root I/O virtualization takes out that middle stop, the hypervisor, and allows you to go directly from the network right into the virtual machine. And so what it means is that now they can get the same performance as if they were running on the bare metal.
In HPC, the processor should be going 100% of the time on a science question, not on a communication question. This is why the offload capability of Mellanox's network is critical. With Comet, the Open Science Grid came in and built their native environment so everything worked as it would in their own lab.
What made this a huge success is that the same soft stack that we already knew that worked in all these different communities, thanks to the virtual interfaces, we could just export it, put it into the virtual interfaces, and then we will have no problem knowing that this will work straight out of the box.
It's probably the most open, the most adjustable of any cluster that we've seen, and what makes that happen is its virtual cluster interface. The science result in this case is a huge deal. What they have done on Comet is that they have unambiguously determined that yes, indeed, what we saw there is not noise and is of actual origin of two black holes colliding. LIGO happened to be on just when that passed through Earth. It's kind of an amazing thing if you think about it.
Those are the very satisfying moments. Seeing the discovery happen and actually participating in it is just that extra bit of knowing that you're part of something huge.